Hey, welcome everyone. I'm Dave Evans from Fictiv. I'm happy to be here with Andrew, say hello, and
Hi.
Terrence, say
How's it
hi.
going?
Super excited. This is our first ever live teardown that we're doing, and we're fortunate to be able to have the creators and the industrial design and the mechanical lead for the Alpine headphones. Pretty awesome. So hopefully to kick things off, maybe I'll give a little bit of a background on the Alpine headphones, and then we'll kick it over to Terrence on some of the ID.
Sure thing.
So these are really interesting headphones. So Alpine obviously is a major audio stereo company, and they introduced these headphones a year ago?
A year ago.
About a year ago. And what's really cool about it is that not only can you listen to the music, but you can actually feel it too. Which I think is just fantastic. I'm an EDM fan. Usually when I'm in front of SolidWorks and I'm sitting there headbanging, cranking out some CADs. So nothing better than to feel the music a little bit. Maybe before we get into the ID, a quick hello. So we're from Fictiv. We obviously are a manufacturing company, and we do this teardown series to really show people how products are made. We really believe in education. We're really fortunate to be able to tear things down, but also have the experts to tell us about it. You may want to tell us a little bit about LUNAR and what you guys do.
Absolutely. Hi, I'm Andrew Zee. I'm Director of Engineering at LUNAR. We are a little company that's been around a little over 30 years, and we do a lot of integrated industrial design and engineering programs, and the Alpine headphones are a great example of that. We really believe that design works best when you put designers and engineers together in the same room and working out all the issues from the get-go.
That's really awesome. Yeah, I think that we're fortunate to be in the Bay Area where we get to partner with smart folks like yourself, and it's really great to see. So thanks again for having us.
Thank you.
So Terrence, obviously, headphones, right? Everyone wears them. Everyone has them. Can you tell me a little bit of what made these different and your thought process behind some of the ID on it?
Yeah, definitely. I won't rob too much from the technical side of it, but I think it's helpful to kind of start off with how it all came to be and how it came to fruition.
Beautiful, I love it.
So Alpine kind of approached us early on, and there was kind of a skunkworks team that exists there, and they had really wanted to get into the audio but more lifestyle approach.
Okay.
And so they did have a group that came up with this idea of how do you add physical sensation
Like
into
feeling
audio.
to it,
Yeah,
right?
like so when you think about Alpine, you imagine the old like '90s in-car sound systems, right?
My first stereo system was actually an Alpine. I had two 10-inch subwoofers in the back of my Yukon.
Exactly, yeah.
Yeah, annoying high school
And when
kid.
it hits, you
Yeah.
completely feel that. So they wanted to find a way to translate that, and they very much did so. So
Cool.
their team internally came up with a really roughed up version of a transducer.
Okay.
It was much larger than this.
Yeah.
It's a pretty big block. Inside with some technical functionality, PC board, and
Okay.
it gave that sensation and that physical kick.
Yeah.
And so that vibration matched with the sound, and it gave them the right effect they wanted. So when they approached LUNAR,
Yeah.
the goal was how do we make this massive thing become a
So did you
headphone.
literally have this box that you would like sit on your head with some speakers?
it was wired separately. You did have to hold it aside though, put it on. I think Andrew, you might have tried it out, right? There are a few iterations
Yeah.
of that.
There's a funny story to that, because it was one of those like, why design another headphone? Because
Right.
they wanted to
Yeah.
extend the brand and reach a younger audience, but like there are so many headphones out there. Why do another one?
Another set of headphones.
But when we listened to it and felt it, it was
Yeah.
like that was it.
Wow.
We knew we had to work on it.
Yep.
That's cool.
Yeah, absolutely. And so from there, we went the whole exploratory route, right? So we worked with their team, we collaborated, thought of what's strong in their brand, what makes Alpine what they are, and what
Yep.
visually works for them. So
Yeah.
in that entire journey, what we really came down to is one of the really big core graphical values for Alpine products
Yeah.
is it's these 5 strikes that you normally see. So
Yeah.
hopefully that's on
Yep.
there. You can see that. The 5 strikes, and they are led on by a 45-degree angle. So that's a really strong characteristic.
Yep.
You can kind of see that in the logo on the
Same one
side.
there. Yeah.
Exactly. So that's kind of the starting point we went with, right? So how do we add the physical expression to that, and how does that all tie into the brand, right?
Yeah.
So across the board, what we eventually ended up doing was finding a real strong character in the fact that the 45 was something that could help shape what makes this
So
what
you
it
actually
is.
took that angle.
We took that angle, made it its character. So you kind of wonder, why is it a diamond, right? And so
Yeah.
just purely geometrically, when you lay it on its side,
Yep.
it allows this band to become the 45 strike.
I got it. So if we almost sat it here so everyone can kind of
Exactly.
see, it's a 45-degree angle
Yeah.
off that parallel surface.
And that's
Wow.
really what brings in, kind of introduces what the newer lifestyle brand could be for all of it.
Yeah.
After that, a lot of the design characteristics really came from this notion, the idea of a physical kick,
Yeah.
a vibration.
Yeah.
We took that idea of the vibration as a means of translating the diamond,
Mm-hmm.
which now graphically shapes into this outer stingray,
Yeah.
which translates to the outer band. So you kind of see a layering effect that occurs on this visually.
Wow.
And that whole idea was to bring in that essence of physicality into it. So we took the opportunity to kind of translate that into the packaging as well.
Yeah.
And a lot of the kind of online marketing stuff. So
So one question I have, I think you describe it beautifully. I'm the Mechie, so breaking it down for me, what does that process even look like for you? I mean, are you sketching? Is it in 3D CAD? Are you in my Blender? What do you
Sure,
do
yeah.
to do that? Yeah.
I think the first part is most certainly sketching, right? So
Sketching.
getting right down to it. It actually started with a session with the Alpine team.
Yeah.
Everybody got Sharpies and we
Yeah.
got paper laid out, and anything counted, right?
Cool.
So you can sketch, you can come up with any idea.
love
There's no limitation. And then when you get to a certain point, you kind of decide, okay, so what are the really strong elements that everyone thought of? And you reel it back, and that kind of creates buckets that you kind of expand upon.
Cool.
And so with that, that's when we start getting into CAD. We start making really rough models or
Yeah.
mock-ups.
Yeah.
So putting things in the bands
Yeah.
over the years.
Yeah.
And then engineering got real nitty-gritty to find out, what are the flex strengths of some of those things, right?
Yeah.
And that works really well. At LUNAR, we definitely integrate the engineering and design together, and this is a perfect example of that.
Yeah.
There were iterations of this that certainly couldn't flex and fold and compact the way you
Yeah.
wanted to. But engineering has amazing solutions that combines the two, right?
I love the healthy tension is what I'll call it between design and
Yes.
engineering. Like, oh, your
Totally.
stingray is really nice, but
We're holding back our jabs.
Yeah, totally.
Now.
Yeah.
doesn't get any better than that. And maybe just for everyone out there, what is your CAD tool of choice as a designer?
For me,
Yeah.
I use Rhino.
You're a Rhino
yeah,
guy?
so I'm a Rhino guy.
Awesome.
Yeah.
So surfacing passed over to probably more
Yeah.
parametric modeling.
Yeah.
afterwards.
It is actually, we do a lot of that.
Yeah.
Some of the industrial design is in SolidWorks,
Yep.
but in the engineering team is SolidWorks or Creo.
Cool.
But most of these we recreate anyway because in order to hand off to manufacturing
Yeah.
and make adjustments, it just makes a lot more
Just
sense.
easier on there. Well, that's so cool. I love the way it almost floats, and I think what's so unique is headphones, like you say, are everywhere.
Yeah.
But everyone has a little different, unique approach for how it came about, and there's a very distinctive style to these for sure, which is super cool.
Yep.
So
That was actually very interesting because making that diamond shape, that square
Yeah.
shape, was a challenge because the headphones, the ear cups want to be round.
yes,
Because it's
and every
follows the
manufacturer
shape.
wants them to be round.
Right, so we actually went back and forth a lot to get to a size that can still be completely over the ear
Yeah.
and not be so big and bulky
Yep.
because there's extra space around the round. Also, we went through a lot of iteration just on ergonomics
Yeah.
for those ear cups.
Yeah, the cushioning alone I thought was an interesting element because when we started shaping those, it's like you're saying, right? There's that challenge of how do you prototype and mock those out and try them real quick. We were actually very lucky. At the time, we had an engineer's sister on this project who happened to
Yes,
do
right.
leather stitching.
Wow.
And so it was really nice because she had recently started getting into much more premium leathers,
Yeah.
really fine detail stitches.
Yeah.
So we were able to mock up a lot of these different diamond shapes.
Using-
And if you look on the inside, you can kind of see this
this
round
camera
oblong
right
that's
here.
inside
Yeah.
there.
Yeah.
And so those details were kind of explored by just quick iterations of just leather
Yeah,
stitch.
you kind of see.
And then we got some pieces of foam, kind of chunked those out as well. So that was a really kind of combination of serendipity and what really worked well for
Yeah.
us.
Yep.
I think what's so interesting too, and maybe we'll get into this as we tear it
Yeah.
apart, whenever you combine soft goods with plastics,
Yep.
with then there's actually a BLE in here as well, so electronics and Bluetooth, those vendors don't play well with each other, and trying to get that, we do a lot of wearables, as I'm sure you guys do, and it's a really hard domain. So it sounds like even having that sister in the early days really helped shape some of this product or
totally,
whatever.
yeah.
Yeah. Well, I mean, we came here to tear this down, so
Yes.
should we probably do that teardown thing?
Please do.
Okay, all right. So I have to admit I don't know quite how to get into these, so I'm gonna take my best guess, and then maybe you can help me from there. So really cool features for everyone, really close. I love that most headphones, you have the earpiece that actually comes down and below. It's actually the cups on these which move, which I think is really fascinating. So you keep this this band the same the whole time. For DJ, I assume that these swivel, which I'm sure we're going to get into some nerdy discussions on mechanical designs for this. And then the overmolding is just fantastic here, and the different material choices. So I think the Teardown, we'll probably try and pop these guys off first, and we'll start there.
Hopefully it'll make some sense.
Hopefully it makes some sense.
One of the things is it's not meant to be easily taken apart because we actually don't want users to take them apart.
But if it goes together, it has to come apart some way, and that's part of the fun. And snap fits are everywhere.
Yeah.
I think the other cool part is there's no visible fasteners, which I know is always a challenge. Did any of your early prototypes maybe have fasteners in it? Or?
A little bit. Some of the earlier hacks we would, but we knew from the get-go it's always a goal to hide as many fasteners as possible.
Yeah, and that's what you can kind of see in these covers here that we're taking off. That try not to break any of these, but we can see that even in our first get-go, we have 4 fasteners underneath, covered by just little caps.
Yeah. It's always a trade-off between how secure you want it to be, and these things have to survive a 6-foot drop. So we
a 6-foot drop test.
We had to put some screws in it.
That's really awesome. And so, at what point did you start doing the 6-foot drop test? Maybe as I'm taking it apart.
It's really early on. So one of the things that we actually participated in is we helped Alpine find a supply chain that is outside their normal supply chain because they are mostly into car audio systems. So their supply chain is not really suited for this, and also they tend to move a little bit more slowly. So our goal was to basically get everything, ramp up the supply chain, and get the product design.
So you guys went all the way through then.
In less than a year, and I think we ended up hitting 9 months.
Wow, 9 months to get this thing to market.
Yeah, it was a quick.
Oh my gosh! And I'm glad you guys put Loctite on this because one screw's not going to come out, but maybe not. Most of them are coming. Am I doing this right so far? What do you think? Yeah. Okay. Tearing down's always an exploration. I think this is literally an Emmy's dream, is to take things apart.
Well, it's why we do this, right? You can see all the stuff behind us. It's part of a lot of reason why the engineers are in the business of design and engineering, because we love tearing things apart as kids.
And so for some reason they're like, hey, do you know as a profession you can do this too?
I know,
and continue to tear things about? How about as an industrial designer? Are you taking things apart, or more you're fascinated at every surface?
So if it was me, for my personal path, it was about that actually.
Okay.
I actually grew up in a household where all of my family members were either car mechanics, restored cars, or worked on cars. So that was a thing I kind of always grew up around. So I've put together, 4-cylinder, 6-cylinder, 8-cylinder engines before.
Are you sure you're a designer? Or
so that was an interesting thing. I fell upon that. Later on, I discovered there was this other side. I loved illustrating and drawing, and then found out there was something that kind of married the two.
Yeah.
Took that gamble, and I think it went down that right balance path. That's where I'm at right now.
Well, you obviously have a beautiful aesthetic with the way you've designed these, so I think that's incredible. Yeah. What do you think?
These guys are also snapped together because this is another one of those where we knew we had to control how tightly the parts fit together. So besides the screws, all the edges are snapped together at the corners. There you go.
Wow, so you actually both fasten it down with 4 fasteners as well as snap it. But these aren't permanent snaps, or?
They're I guess fairly secure, but if you pry it hard enough, they'll come apart.
So what you guys are seeing here is what we're talking about. Finn, can we see that up close or not? So basically what we're seeing is that we have these snaps that are in each of the corners, that they're permanent snaps, or just tightly held snaps, I would say. And some really interesting piece as well is wire routing. I think that's always a challenge whenever you're dealing with it. But you can see internally that we have a lot of routing places for these.
Yeah, and that actually, we spent time designing that surface loop because the ear cup slides up and down. There's actually a service loop. The wire has to travel back and forth without you putting a lot of tension on it.
And we can kind of see here really quickly that we're seeing that slide mechanism that happens here. I already can kind of tell how this works, but maybe you want to describe this mechanism that we have.
Yeah, so there's a heat-treated spring steel, so that
Yep.
creates a little detent.
Yep.
And it slides on a track that has bumps in it. So every 3 millimeters or so, you got a little bit of detent to give you that range of motion.
Yeah.
Yeah.
So if you guys can't see, what's really cool is that we actually have this material here with those 3 millimeter gaps on it. There's some lube of some sort on it to help it slide, but this is almost freestanding and sliding because we have degrees of freedom, I guess, just in one axis here,
Yep.
right?
Yeah, so there's a couple of axes because there's a little bit of swivel.
Okay.
And basically,
Yep.
one of the tricky things is squeezing that all into one joint,
Yep.
which is different than a lot of headphones out on the market,
Yep.
and also running the wire through it.
Oh wow! Because you got to run the wire through and get a little bit of play in your X, and
Yeah.
then full in your Y, or at least 10 degrees or so.
If we're lucky and we get everything apart, we may be able to pop that ball joint out.
Pop the ball. Okay. Let's see if we can get these screws
Yeah,
off here.
those should be able to come off.
I might need a bigger screwdriver though, so I don't strip this. Can we get a bigger Phillips if we have one?
Is that Phillips, or they may have used? No, that's a Phillips.
Yeah,
it's
it
not
is a
Parks.
Phillips. Yeah. But some other cool things. So we have heat stake inserts here, which are brass inserts. These are great for prototyping. People use them all the time. Great for production as well, as you guys have used them. Maybe as we're getting one more, this is a pretty cool mechanism. Do we want to talk about this mechanism right here that swivels? Whoa. Did I
Yeah,
break
that
something?
one.
Yeah.
Yeah, that one may come out. So
Yeah.
so basically, that one I can show you an earlier iteration of.
Yep.
Yeah, that's perfect. So all the detent is built into the shaft. So
This shaft
we
here?
managed to get rid of all.
Yeah,
the
maybe show us an
complex
early
features.
prototype. Yeah.
There was an earlier version where we did not do that and just didn't feel as nice. So I don't know if
Yeah.
the top camera,
Yeah.
we had snaps on the outside.
Uh-huh.
That didn't quite work because of the way it interacted with the part when you're rotating it.
Oh.
It kind of gets
It
stuck.
gets stuck on one way. So what he's showing here, we have a high resolution 3D print. It
Yeah.
looks like, and if we turn it, we can actually see right here that we have this almost like a snap fit or just
Yeah,
an
it's a ramp
interference fit.
snap.
Yep.
So the
so does it
intent's
turn-
the same. It basically pushes the whole headband out on the spring and it
Yep.
pulls it back in.
Yep.
But it does it in a not very elegant way, and it doesn't look pretty when you turn it. So
Yeah.
you can still see the detent. So
Yeah.
we actually rethought how it all worked, and
Yeah.
we managed to squeeze everything into onto the shaft itself and do all the camming and detenting.
And so what we'll show here is that
Inside.
you can actually see that where we have the spring loaded, which is providing our tension.
Yep.
We then have a metal stamp piece out of a stainless
Right.
or some type of steel probably. And then what's actually holding this in place, this stopper piece right here?
So that is actually trapped in that groove there, and then once the other half goes on, it's permanently
It's sandwiched
Yeah.
together. But we can actually almost
Yeah,
take
you
it,
should be able to pop it up.
just pop it off maybe.
Yeah, maybe you stuck something underneath. Yep.
Oh, yeah.
There you go.
Perfect. So you can actually see, and it's probably is it just stamped?
Yeah.
Sheet metal? Something?
Yeah. So things are designed for as simple an assembly process as possible you could get on a headphone.
Let me tell you, if you can do DFA, design for assembly, in 9 months and still produce it, I'm pretty impressed. Usually, maybe on V2, you're optimizing for some of that. So let's see if we can take this off, because that's the rocker you're talking about is on
Yeah.
here, right? If we do this right, we might be able to get here.
Yeah, it actually comes apart easily.
Yep. So this is pretty cool as well. Just another little spring. Thank you. And so that's what's actually creating the tension there. What do you think? It's the best way?
That one, you just need to apply a little bit of force to pop it up, but you may want to do it after you take apart everything else.
Yeah, the ear
ear
cup.
cups also snap off the foam part.
Kind of
anyway.
hear it. Oh wow, this is cool. So this is an injection molded part. So we can obviously see the different ejector pins on the outside, and then it's just glued or adhesive on.
Adhesive leather.
Yeah.
But we learned a lot about this because there are suppliers who specialize in making that entire assembly.
Yeah.
There's a layer of mesh that protects you from
That's this here.
speaker from dust.
Yep.
And there are actually different foams in multi-layers that are different stiffnesses to give you the feel that gives you gives it the structure, and then it gives it the softness that you need right around the
Kind
ears.
of this feel. And did you guys have to prototype a lot during that?
We prototype a lot. So one of the benefits of getting supply chain on board early is we work with a supply chain to get a
actually
lot
do
of
that.
these prototypes.
And when you're saying early, what's early, in that process?
Early in the process, I think we've got the suppliers identified halfway through our engineering process.
Halfway through. Got it. Just to show, because I think it's really interesting mixing these different goods. So we have the leather outside, which you're talking about. I assume this was done overseas.
Yeah, this is overseas. We tried out a whole bunch of leather, all the way from Italian suede to.
I remember all the samples.
Yes.
Yeah, there were a lot to choose
things from Korea, things from China.
Yeah.
I forget where we ended
You can
up.
actually see this here. So this is the leather you're talking about. It's all stitched, and then you have one set of foam here, and then another set. And so for me, I haven't done much soft goods. Do you still deal in durometer? Like how do you measure the hardness of a foam?
With foams, we don't.
Okay.
I think we just basically get samples and pick ones that we think are
Feel.
good, and then they go from there.
And is it purely a feel thing for someone like
a
you?
lot of
where
it
you're
was
like,
so
that's
there's that
nice.
first interpretation of how does it feel in your hand, right?
Yeah.
You feel a certain way, but then you got to put it against your head, right? And
Yeah.
it's really trying out those two.
And also testing out for compression, because you want
yeah.
it soft to feel comfortable,
Yeah.
but it can't squish so far that your ears ended up hitting the plastic inside. So we
Yeah.
actually had to dial that
How
in
to get
several
this? So like,
times.
how does this feel?
Yeah, and we'll see once you get into the band, then you realize it's also a combination of how much flex the band has.
So I think this is really interesting. Is this just glued on here? It looks like.
Right, but there's several layers as well of other materials to support the foam and
Yep.
then glued together.
If you're gonna tear it apart, you really got to get down. So injection molded,
Yes.
probably a PC or an ABS or something.
I believe most of the parts are ABS,
Most are
except
ABS.
for one of them where we'll talk about where there's a high wear, so that's a glass-filled nylon.
Got it. So then we have some type of, it's just a foam.
Yeah, that's a stiff foam that
stiff
serves
foam.
as the backing,
Yep.
and that's the foundation for everything else that's glued onto it.
Yeah, and then there's actually two, right? There's like a thick adhesive, or I'm not even.
Yeah, that one I think they had to do because on that guy they have to work around the connector ports, so that lifts it up and gives
Yeah.
it a little bit of stiffness.
So a lot of adhesive. I mean, we're not even in all the way through. We already
We're
have
just
one
on the
material,
ear cup.
2, 3, 4, 5. We have 6 different materials in the ear cup alone. Could probably spend the entire episode on an ear cup, but maybe we'll move on to some of the more exciting pieces. So obviously we have the speaker here.
Right, and those are also easily taken apart, the
Yep.
4 screws.
4 screws. Let's see if we can get that apart. Tell you, when we do this ourselves, it's a lot more guesswork than, well, this is an ABS and this is this foam, and it's more guessing. So I kind of feel like I'm cheating right now, having the inventors sit right next to us. It's pretty fun. Do you know how many fasteners are in this altogether?
I don't have a count off the top of my head, but
Okay.
it's not as many as you think.
Yeah,
I
yeah,
think
yeah.
maybe it's 10%, maybe about 20.
Yeah. So again, we're seeing here we have routing for the wires, which is really interesting. Looks like it's just pressed in there.
Yep.
And it's built into the injection molded piece. We'll go ahead and take the center screw out.
Yep. So that one is what retains the ball detent on middle. Now you can pop out the.
That's cool. So you can see the ball detent right in the middle, and it's just being held in place by a piece of stamped metal with a screw that goes through it. And as we take this out, oh, that's so awesome. It's a little rocker that it just pops into there. And this is one piece, I assume?
This is all one piece. And I believe that's a POM.
Oh, really?
It's a molded
Yep.
Delrin.
Yep. Palm. Yep. Delrin, palm, all the same stuff. And it's a really thick piece, too. Just in terms of
Right.
injection molding, it's actually a really thick part in there. Wow. And is this all one piece? Is this?
Yep.
Tell me maybe about the finish and how you guys came up with that.
Yeah, so this is we went back and forth a lot. We originally wanted this to be real metal, but because there's actually a Bluetooth module in
Yep,
there, we
yep.
had to let the wireless signal come through. So that's actually something called an NCVM, non-conductive vapor metallization. So
Yep.
it looks like metal, but it's actually not conductive.
I'll slow that down for everyone. NCVM.
yes.
conductive vaporized metal, right? And that process is just a dip.
It's actually a vacuum deposition process.
Oh, it is. Yeah. Okay, that's awesome. Should I just, maybe we'll cut the wire, or we can show. So this is obviously where a lot of the brains are,
yep.
I would assume. So maybe walk me through what we're looking at here.
So that's the main board, right? So the controller and the Bluetooth, everything is on there.
Yep.
The other side you will see is less busy, except the other side houses the battery.
Okay. So maybe we'll go ahead and take it out of here.
Yeah. Yeah, this was a challenging time. Because of the layering, we actually had to really make sure everything is as thin as possible because we have added thickness to it.
Yep.
And this is something where the anal engineers in California are forcing the guys in Taiwan to design for everything.
Yep.
So we make them route the wires, stick everything down,
But it's beautiful. I mean, it's like even as you unfold and look inside, the attention to detail on the inside is more than even the outside. Possibly, it's really gorgeous. All of this. Is there another screw, or should this just come out?
There is a couple of screws that hold it from the inside, if we can find. There's one there.
Yep.
Yeah, I think it just temporarily holds it in place.
Yep. That's cool. And do you guys do all the electronics work yourself here as well?
No. So electronics, this one, the client came to us. They have a very good hardware and firmware engineer.
Yep.
And then that got transferred over to the electronics team at the supply chain.
Yep. So I just pulled that out so everyone can see. So we have one driver, right? It's just this one.
Yep. It's a 40 millimeter driver.
40 millimeter driver. Perfect. I'm gonna break it, but maybe it's probably glued in there.
Yeah, that one's it's a pressure sensitive adhesive, so that's how they usually assemble these things. Let's see if we can pop it out.
Whoopsies.
Yeah, so there you go. So yeah, one of the keys to this was we picked a supplier who made their own drivers because we figured that with that level of integration, they're going to give us the better sound quality. So even without the transducer, the bass, these are pretty good speakers, and we actually work with an audio acoustic engineer to dial in the response curve, so it's actually relatively flat throughout the entire spectrum.
Yeah.
That's awesome. One thing I noticed, which I think is always awesome for consumer electronics, if we can zoom in, we have a little mini light pipe here. So light pipes are fascinating for me. Nobody talks about them, but they're in every device that we own. Maybe talk a little bit about how you made this light pipe or even prototyped it.
Right, so this is one of those that was a little bit challenging because you always, when you try to put a light pipe right next to where the switch is, you're running out of space.
Yes.
Right, so we actually had to put.
So we have a little switch right there with a light pipe. I'll pop it out as you're talking about
offset, because on the board they're very close to each other, and basically the good news is we knew we only had to light a small area.
Yeah.
So it wasn't that hard to do. So we actually reflected it off the bottom edge and bounced it up, and it was enough for you to see the light. And the part, if I recall correctly, we ended up it's painted and laser etched to reveal the light. So this is entirely molded in clear polycarbonate.
So I'm going to just slow that down because I think light pipes were always fascinating.
Yeah.
So it's a single molded polycarbonate part. We've then masked it and painted this, and then we laser etched that little dot off of it. So what you guys couldn't see here is that there's a button right there. This sits onto the button right above where my finger is, and it gets heat staked, which means you take this hole and you basically mushroom it. You just put a soldering iron more or less on top, which holds this in place. And then all the light is piped through this actual piece and just shines out where the black paint is. That's beautiful engineering. That's about as nerdy as it gets, I think. When you're like, this light pipe is amazing, but it's like it's a piece of plastic like this that I think a lot of people that know it just really take appreciation to the detail of that.
It's the small details take the most work.
Yep, for sure, and it's spring loaded, as you can kind of see here as well. So that as you push it, it's obviously pushing on a button. Talking about the board a little bit, which I think is interesting, you obviously have to design a custom shape on the board.
Right.
And something that's always difficult is having components come off of it. Can you talk about the mating or the tolerance that you need to actually have the ports that it will connect to and how it fits in here? I mean, the tolerance is really tight, it seems like.
Yeah, I'm glad you asked. It's one of those things that we are a stickler about because we work with the manufacturers so much that you often see, and those of you out there who've worked with a lot of suppliers before, usually they will put 4 screws in it and make them a little bit sloppy and it's going to be floating all over the place. Yeah. We always insist on having alignment features.
You do.
So on this product, I don't know if you can see that.
You can do the top down, yeah.
You can actually see pin and slot.
Here,
so it's aligned, centered.
Yep.
And the end closest to the connectors is where it's very tightly controlled. So it's as close as you can get to perfect alignment between the opening and where the connector is.
Yeah. That's fascinating. So I'll break that down one more time. So what we have is we have 3 different connectors on this end. We then have a pin here, which is controlling the XY position or the flat plane position. But then on this back side, because we have to have some tolerance in the manufacturing, we actually have a slider in so it can be a little bit out of spec or within that tolerance, you'd say.
On that dimension, but it keeps it from being angled in the wrong way.
Because there's nothing worse that consumers notice when you get your consumer electronics and it looks like that. Right. It's a little bit out, or it's actually off axis, and it just looks cheap, I would say. That's really awesome. So maybe we don't have to get into depth, but for all of our double E's out there, can you tell me some of what's going on the board here?
Yeah, the board side, not as much other than there is a Bluetooth module.
That's this guy.
The signal processors is also here.
Okay.
And because this is a wired headphone, it's still analog signals into and out of the audio jack, as you pointed out.
And so why do you need the Bluetooth if there's an audio jack?
Good question. So this headphone has a unique feature. It allows you to pair to an app on your phone.
Yep.
And actually you can customize your equalization. So if you remember your car audio days, you can adjust the bass, the mid-range. And with this headphone, you can do that.
That's really awesome.
And it will remember your settings for certain genres of music or certain playlists, and
really?
it will adjust it accordingly.
That's so cool. I'm sure it presented a big challenge of having some Bluetooth in it because it sounded like it changed all the manufacturing processes. But it sounds like it was worth it in the end.
Right. Yeah, definitely. That was one of the key differentiations because up to this time, most headphones are passive.
Yeah.
And now with all the digital headphones, you may have more control over it. That this is really the first time you're actually having the ability to interact with the phone.
Was that a requirement on the design side? Was to have that interaction?
It was for this particular model that was exactly the case. Yeah. And there was a lot of really huge wins that engineering was able to support, right? So some of the angling for the plug, this custom PC board. I mean, those are the kind of things that, oftentimes you get probably massive pushback, right? And I think it's because of engineering's, experience in doing that with the manufacturer. It got us to kind of that form factor and retain the concept the way we wanted it.
I think that's so awesome. I mean, you can see, just so everyone can, again, that's the button that we were pushing. That's the light that you're seeing, the little LED for the light pipe. So this would just sit right in front of it, just like that. And then obviously your 3.5 millimeter jack, and then this is for power, I assume.
USB power.
USB power, so it's all battery operated, which I assume is on the other side. Cool. Maybe let's dig in. So I'm going to go ahead and take this off. I assume it's the exact same, or should we rip that apart as well?
It's almost the same. So we managed to use the same part left and right, so you can see where these features that are not being used is actually on the other side for the battery.
It's for the battery. Oh, okay. So that'll be interesting. So these are actually mirrored. Are these all mirrored as well?
We mirrored as many as we could. The outside, what we were calling the Stingray, we couldn't because the logo's on the
Got it.
side.
Yep. Where's my little... There we go. We'll try this guy.
In a little bit tighter,
there we go. Oops, as I break everything. Well, we've already done that, so we'll take that apart. Let's get the screws next. Be a great surgeon, I think, just taking things apart.
Oh, yeah. Not sure my hands are steady enough for that, though.
Mine definitely aren't. My partner is actually is a doctor, so she's the real surgeon, I would say. I get to just take plastic apart. So she takes humans apart. I get to do consumer electronics. I have the easier job. Oh, there's the magnet.
It should be okay.
That's fine. So let's go ahead and pop that. Oh, there we go. So we can see the battery on this side, and that's the mirror that you're talking about, right? And then it's just a regulator or something. This board
for the battery.
For the battery. Yep. So we have the battery here, which if we can take this out, the battery sits in the exact same. We can see the mirror between these two. We have the same joint here, and again, great wire management with extra slack.
Right. And there's a little bit of trickiness because the charging is on the other side, so we actually have to route the wiring through the headband.
The stuff you don't think about.
To the battery and then back.
So the battery goes here through the regulator, wires come in, wires come up around it into the other side.
Right. And then, of course, from there, it's also back here for the stereo.
For the stereo. That's really interesting. Cool. So maybe I'll just go ahead and cut that, I think, because we don't really... These? No, those aren't colors. Do we have?
Yeah.
All right. Exacto Nash. We got the tools. Okay, cool. So we got that piece. We said these are mirrors of each other. These ones, the black guys, right?
And I was going to say absolutely yes, but now I just noticed they're left and right.
There is a left and right? Uh-oh, so they're not. You can.
So they could have been, this is a family tool.
It's a family tool.
This is a one
Maybe help describe what a family tool is for folks out there.
So because a lot of times suppliers match tools for the quantities per unit, so because there's mostly one of the headbands, but two of everything in the ear cups, these two parts are molded together, I believe, actually maybe end to end this way in one mold base.
Yeah.
And same thing with these two guys.
Yeah, will be molded together. And a lot of times we do that for consistency and color too, so that they're shot together. You can imagine that if these are different, you might have a different mix for your black ABS that's done. It's the small things. Well, this is probably the most interesting, I think, obviously the joint and rotation. Before I get into it, or maybe as we go through it, can you talk a little bit about some of the prototyping that you did to get to a band that has, this type of spring and force on it? Yeah.
So that was actually one of the more challenging aspects besides all the other mechanical trickery we had to do in the hinges and the joints, because the success of this product really depended on the headband working, because that's where the vibration is generated,
which is up here,
and transmitted into your skull. But it's also transmitted down the sides into the ear cups, because you actually can feel a bit of that vibration through bone conduction on the ear cups despite the padding.
Got it.
So we knew it was important to get that structure to be as stiff as possible and provide a certain level of clamping force that you may not actually need to achieve in the
clamping force being this way, right?
In pressure on the ear, exactly. So we ended up actually needing to put a piece of spring steel inside, if I can find some of the earlier prototypes.
Who doesn't love prototype? This guy does. Wow.
And earlier prototypes of what the transducer looks like inside.
So this is the transducer, so everyone can see. This is providing the vibration. I love this. We have two different layers of foam. We have some plastic, probably modded from another headphones or something.
And we tested multiple thicknesses of steel.
Yep. So
heat treated. That's why it looks like that.
And so talk to me. So this would have been manufactured or prototype flat, right? It's going to be stamped or water jet.
And then they stamped it.
And then they stamp it this way.
Oh, actually, this one, because it curls back on itself, I don't believe they can. So I think it's rolled.
Oh, that's probably true. And you probably would have to roll it to here, so you have a spring back force on it.
So that's the magic that the supplier brings. We rely on them to figure it out. But one of the things that was important that before it gets into production is how do you know it gives you the same clamping force every time? So we actually made them do a go no go gauge. So we test the spring on the steel before they put it in.
Oh,
really? Because once they put it in, they can't take it out again. So.
And what does that look like? What did that gauge actually look like?
So there's a little test jig that has fixtures, pressure sensors on either side of the fixture. So when you put it on, it actually presses down with a certain force, and they measure it and they record it. As long as I think we gave them a range of, I think we were hoping to achieve plus minus 5%, but I think we ended up somewhere around 10%.
Got 5 to 10% on a go no go for this. And I know that you guys said you prototyped. It's really, if I understand the stiffness correctly, we got to look at the thickness or the width as well as the thickness, right?
With a little bit, but if
Yep.
I remember my formulas
Yep,
correctly, it's a
please.
cubic relationship to the thickness. So a little bit increase in thickness, the stiffness increase to the
cubic
right?
factor of
So it's really sensitive to thickness. So we have to balance because we don't want to make it too heavy.
Okay.
But we need to make sure it clamps down with enough force.
So I think that's a really interesting thing you just said. There's a formula which everyone learns in school of how to do this, but then there's a feeling as well, right?
Yeah.
Well, yeah, your formula says the force is this, but my ears get tired over time.
Right.
And it sounds like it really was, we have a formula to get us in a ballpark,
Yep.
but then there's nothing you can do better than maybe just actually making a bunch of prototypes.
Yes, and making people wear it for 2 hours at a time.
Exactly. Yeah.
Yeah, I mean, it's great, right? We're looking at an ABS prototype, just FDM,
FDM.
rough print, and then it's just so cool. All right, let's get into the real thing. All right, so I think we talked about this before. You said it slides or something,
Yeah,
right?
so this one is tricky because we're really designed to not come apart. So if you can pop the ends off, it would slide because there are hooks that. So
pop
you might
these.
you might need to use a
tool
spudger
yeah.
pop those end bits off. Yeah, there
Yep.
you go.
I
Both
see.
ends and these ends, and you can hopefully push them apart.
I would have dremeled this by now if I was on my own. No.
Yeah, this one we actually went through also a couple iterations. You can see, I don't know how well this one shows up. The earlier prototypes are all snapped together. And they just didn't hold it together enough to create a consistent gap, especially when you're doing this
Yep.
to
Yeah.
the headphone,
Yeah.
right? When you do that, it comes apart. And these things, the amount of testing and the type of testing they put them through is insane.
Just to go this way?
So the cycle testing, I think it's a couple thousand cycles, stretching it to 100%,
100%, yeah.
and also twisting 180
Wow.
both ways.
Wow.
So these actually are designed to take quite a bit of views.
And is that a machine that's actually going to
There's
hold
a-
each of these?
They
and
have a
it's gonna go
machine
way?
that goes and twists it.
Yeah. Yeah. And so with that we got a question from the audience, which I think is really awesome here. I'll read it. How much market research was involved in defining the form and fit of this? This is from Parker, so thank you. Maybe talk about that. Did Alpine bring that experience, or did you guys have to do it?
That's a great question, because a lot of times our clients don't bring that, and we would suggest doing research, but a lot of times, because we're lucky that LUNAR has enough people and enough diversity, we use ourselves as test subjects.
Got it.
Often. And of course, if you really want to do proper research, we would set up research and recruit users and test them with that.
Yep.
This one is based on mostly our own sensibility and getting our own folks to try it
Own
out.
folks to try it out. So did you bring
Yeah.
these home one night? Were you walking on BART? You're just like, yeah, I look cool.
One of the interesting elements that kind of worked out nicely was there was this appeal getting
this
on
one
the EDM kind of focus.
Got it.
So in terms of that, we use that kind of as a starting point. And I conveniently happen to love going to music festivals
Oh, really?
regularly.
Yeah.
So I did, in a lot of ways, kind of reflected on what's my general environment of a consumer group,
Yeah.
and how do we bring that point of view in. So this was a different approach in that sense. It was less about a very quantitative way of thinking about the marketing appeal,
Yeah.
and how is it kind of emotionally reactive, right, for someone like myself.
I think that's a really good point that a lot of people think, oh, if I'm going to do market research, I got to go find everyone. But sometimes right around you in your community, you have a sister that does leather stitching, or you go to EDM concerts yourself. So sometimes you are the best
Yeah.
users.
And it doesn't always work out like that,
Yeah.
but I mean, this was a really good example of a
Yeah.
good opportunity for
We,
that.
we often rely on ourselves and extended friends and family.
Yeah.
It's a good way to start. We actually do some user test programs like that,
Yeah.
but we also do a lot of proper research where we actually recruit in multiple cities, even multiple continents, and do observational research or focus groups that way.
That's really awesome. I want to pause here before I take this all apart. The mechanism on this is so cool. I think that if everyone can see here, what we have is it's actually a slider. So because this has to stretch and be pulled so much, you need this to really be fit in tightly and secured on there. And so what you can see is that we have these sliding pins that they're actually captured when it's in that position. But if I pull it this way, it can all come apart. which is really fascinating. It's something we do actually on car doors a lot, that it's the exact same way that it slides into place and snaps in, and there's a few fastening features.
Right. Yeah, because snaps are great and easy for assembly, but again, like I was explaining earlier, in this case, it didn't really do what it needed to do.
Yep.
So we actually had to push the supplier to try that, and they were really opposed because it's harder to assemble. So we actually helped them design an assembly fixture.
You did.
That you can place the old headband on an arched fixture, and there's a grip that actually presses down on the headband evenly, because you need every hook to engage, and you go click. And
it actually slides it this way. So you actually had to build that fixture just to do it.
Right, because otherwise you got to push every single one in, and when you're sliding it, some of them may pop out.
That's awesome. So tell me a little bit what we're looking about here. This is the
That
steel.
is what the steel band ended up looking like, because we had to cut them all out around the places where the hooks go in.
Got it. So these are where all of our hooks go, is right in there.
Yep.
That's awesome. Let's see if we can get this actually.
Yeah, that should come out.
It's the wrong size. It was almost stripped to the other one, so I want to. There we go. Add it to our graveyard of screws. And so as I'm doing this, maybe talk to me a little bit about this overmolding process of, is this a soft or a silicone, or what's the material?
It is actually a liquid silicone rubber.
Okay.
So it's actually injected as a liquid, and it's cured as the mold heats up.
Got it. And what's the cycle time on something like that?
That I'm not so sure, but it's probably over a minute.
Because, over a minute. Wow.
Yeah, because it takes a little bit of time for the parts to cure, and on top of that, because we wanted to achieve the two-tone color, the white band in the middle is deliberately done there to highlight where the technology is.
Yep.
And in order to do the white on black, we actually shoot the white part first, and then the entire part is picked out of one tool, dropped into another one, and the black shot is.
So for the black, then you can actually do it in the same mold then?
Right. So we have a version that's black, and we are able to do it just with a second mold, because we don't need to do the two colors.
Yep. And how did you prototype this actual silicon band here? You know, in the early models of an EVT or you know, maybe the more close to the end. How was that?
It's one of the more challenging processes. I believe there are now actually silicone rapid prototyping.
Cool.
Before that, we always had to use cast urethane.
You did.
So we simulated with a urethane mold and urethane parts. It's not exactly the same.
Yep.
So nowadays, I think that the rapid prototyping process is getting better, so you can do something similar.
Yep.
But this one was challenging.
Yeah. We actually do that a lot. It's RTV mold, so room temperature vulcanization, cast urethane to do these, and we'll take it off just so folks can see. But otherwise, you can actually print in rubbers and stuff now.
Yeah.
We had a great question come in, which was this is from Oscar. Thanks, Oscar. How many MEs, mechanical engineers, were behind the entire process within LUNAR, and maybe how did you divide the work up?
That's actually a fantastic question, because it actually took a lot more effort than I think anybody anticipated. This was one of the projects where we were originally hoping that the supply chain would take over most of the engineering work.
Yep.
But by the time we got to releasing our industrial design to them, we knew how complicated this is getting.
Yep.
So we actually talked to them extensively about how much resource are they putting to the process. So this is where, at the end of the day, I think it involved up to 5 engineers.
5 mechanical engineers? Just purely mechanical.
And originally, the supplier had one poor engineer working on it, and they estimated 1 week to transfer design into production.
Yeah.
And we looked at it, it's like, there is no way you can do this. So we ended up augmenting him with 2 of our full-time engineers, and that turned out not being enough. So we had 3.5 people, and they had 1.5.
Wow.
And we did all of this in about a month.
A month? 5 engineers in 1
mechanical
month, the
engineering
mechanical side.
out of it.
So you're saying from the design, which you worked on, it was 1 month of your time to translate it, get it to manufacturable, and get it out the door.
Right, so which
That's
is
incredible.
usually insane, but after that though, they have a lot of prototyping steps, so we
Yep.
actually didn't skimp on the EVTs and the DVTs, where we actually went through multiple cycles of early prototypes to,
Wow, this is so cool.
that's actually earlier, the EVT 1, 2, and production, almost near production.
EVT1, so you guys can see this is what it looks like. Engineering validation test 1. This would be EVT2, and then we're looking at, this is pre-production, right?
Yep.
Those are
Yes,
those your tooled ones?
Those are the, yes. So yeah, these are still mostly not tooled. You can see these are machined.
Yep.
We actually went through the logo change between 1 and 2. You
Yeah,
can see,
you can see the logo change
which
on
is
those.
why we insisted on the logo change, because the Alpine logo really didn't fit very well on the headphones.
There were a lot of
if you
challenges in
can
the molding of it as well.
what's going
I
on
think there was an
here.
interesting opportunity. At the same time, we also wanted to kind
wanna
of
come back?
strike the right opinion where if Alpine's getting into a different type of device or different product that's different from the in-car, it was really a chance to kind of look at the brand and get it how to refresh
where
it, right?
we ended up
And so that's why you're also seeing a new logo in that way.
here.
I think that's so cool. We got another question coming in here as we're wrapping up. This is from Derek and Julie. Please keep the questions coming. This is awesome. What kind of ergonomic comfort testing did you do to validate decisions about clamping force? You know, ear cup foam stiffness, leather texture. What type of stuff did you do there?
This is back to where we actually relied on a lot of our own internal folks. So we actually made people wear a lot. Of course, the client is the ultimate audience, so they actually tested themselves a lot. And we actually had to try a lot of different foam stiffnesses, a lot of different material. We went through a lot of samples on the leather, from real leather to the faux suedes to polyurethanes.
Yeah. And a follow-up from Derek, just because he had it there, was there a range of size of heads? You know, we all have different width and shapes to our heads.
Yes.
You know, how did you even model for that?
So there are some,
I think we hit on a thread.
Well, we actually did start the project by getting a whole ton of headphones. We tore down a whole bunch of headphones, competitors as well, and they gave us a range to start at. So you get the target, and then from there, that's when you start trying to get the bullseye, right?
Yeah.
And that's where all the testing comes in, and trial and error.
Yep.
Making it and putting it on, I think that's
And even
gotta get
figuring
hands-on.
out the range of travel,
Yeah.
right?
Yep.
So we actually started with Dreyfus data, but we also had CAD models, but we also collection of teardowns, competitive studies, and also relying on what the supplier had, because the supplier specializes in headphones, so they have their own database.
Yeah.
So between all of that, we actually had to figure out how wide to make it, starting, ending, where the top stop is, the bottom stop.
So the three things I heard, that there was a supplier database, there was
Dreyfus,
Dreyfus
and
as
there's
well,
our own user testing.
and then own user testing. I think that's a really good three-prong approach. Another question. I want to get to this really quickly before we answer this last question. I mean, this is the meat of it. You guys said when we started, they walked in with something this big in your hand, and I want to just point out the size of this. Is it a driver, or what would you call this?
So
a transducer?
they call it a transducer because
Okay.
it's actually the driver without the cone.
Yeah. Oh, okay.
So it's a vibrating magnet.
Yep. So just the driver of a speaker without a cone to actually make the sound on it, and it just literally sits right up here.
Yeah.
And it just vibrates this entire piece of
Right.
steel.
So, and unlike how your vibrators work in the phones,
Yep.
this actually works like a subwoofer. So I believe
Yeah.
it's everything below 150 hertz gets passed to this. So it actually vibrates in sync with your beats.
With
which
the
is,
beats?
which is why it feels like a subwoofer.
Wow.
Yeah.
So
That's
that
really
is
cool.
literally subwoofer on your head.
So I can bring back my my high school 16-year-old Dave driving the Denali with Alpines in the back.
Absolutely, yeah.
That's really awesome. Another great question. We're going to keep these coming here. We've already talked about this a little bit, but talk to me about the process between ID and engineering, the healthy tension, if you will. Could you maybe share one moment where loud voices were used, possibly, maybe in polite words, or maybe that never happened because you guys do this really well?
I'll start off with that.
Okay.
I don't
You
think there are
start.
any. I don't think there were any key moments that escalated more than others.
Uh-huh.
It was a constant of that. Probably struck more, I would say, by the ID side.
Yeah.
I think purely from collaboration. It was the teardowns and understanding it how it worked. Right off the
Yeah.
bat was purely the collaboration.
Yeah.
And then when it really got to the little finite details, right? Like we're talking about the flexing and the torsioning. How can we keep the surfaces the same? How can I hide the slider, right? We're even saying for head shape, like how can I get this little rocker to move up and down and still hide the slot?
Yeah.
There were lots of those things that we would constantly approach and say, how badly do you want to hide it? It'd always
Right.
start like that,
Yeah.
and it'd be like real badly.
Okay, we got the
Yeah,
ID
exactly.
side. No, let the man speak.
Yes.
I already know how this went. Andrew, please tell me.
So it is really a lot of back and forth because we actually get involved very early in the design process
Yeah.
to just make sure, hey, are you sure you want to do it? Can we make it? Like the first thing's like, please don't do this because that's going to take extra work because
Yeah.
nobody's done it before.
Yeah.
So, but it's one of those that, okay, if it's that important to the industrial design because we wanted to maintain that continuous
Yeah.
look,
Yeah.
then we go to work and we solve it.
Yeah.
Right. Same thing with, let's try not to make that square
Yeah.
because that's going to be a challenging thing. But again, very important to the design, and
Yeah.
that's what made it iconic. So
Yeah.
we basically worked with the designers to say what's possible, what's
Yeah.
not possible, how big, how small,
Yeah.
what's the feel.
I
and
would say
we
from an
worked it out.
unbiased approach too, that's one of the beauties of going with someone like LUNAR, and something you guys are really good at is the marriage between design and engineering and really building a product in months. Really cool. Another great question on the technical side. So we have a transducer here, which essentially you said is just the speaker. Do you know how this was sourced or that you chose this? I think we said that these were 40 millimeter drivers, right? And this is a little bit smaller. How do you evaluate the differences between them?
That's actually an easier one because
Yep.
the folks at Alpine are so familiar with all audio. They actually selected the transducer together with their acoustic engineer.
Awesome.
The 40 millimeter driver is fairly standard for speakers of this class.
Okay.
I think if you tore down a Beats Studio, it's about the same size, although I would have to say this is a much higher quality driver.
Yeah.
But the transducer, the client selected for us, and then the supply chain basically found their equivalent to match it.
Yeah.
That's really awesome. I want to get into this before we run out of time a little bit.
Right.
So this here would have been stamped as well, and then it's actually bent because we have almost these like snap fits built into this, which are actually 190 degree and two different 90-degree angles. Can you tell me a little bit about this this manufacturing process?
Right, so those are all stamped. They're stamped in the flat, yep. And
It doesn't even spring back. Or I mean, it does spring back.
right, because it's heat treated, it actually stays pretty
Heat treated. Yep.
strong.
Yep.
The hooks are there because it actually has to sandwich the, if you can see this guy,
Yep.
between the plastic parts to just keep it from pulling out.
Pulling out.
So
I
that's
understand.
the sole purpose of the inner structure. It
Yeah.
sandwiches and the hooks basically pull them up.
Yeah, so folks can see that this sits in there, and then these hooks do that.
Right. So
And-
they're stamped first and then rolled.
Yeah. So we're going to stamp it flat, right? And then we're going to do these clips and then roll it.
Yes.
Is that right? Wow.
Yeah, because a little bit hard to bend them after you've rolled it.
Yeah.
So I believe they have a fixture that maybe have cutouts around it. I actually haven't seen that tool,
Yeah.
but they roll it afterwards.
And then maybe talk to me about these guys too. Are these metal injections?
Yeah,
or-
so those are that's actually part of what made
So
it work
cool.
so well. Is
Yeah.
those are metal injection molded.
Can we see that okay
parts.
around there? Yeah. So these are metal injection molded, so everyone knows what we're talking about. It actually starts as a powder, molds it, and then we bake it afterwards.
Yep. It burns off the resin, and
Yep.
you end up with a fairly high precision, high tolerance
Part.
metal part that is more complex than your typical metal castings.
Yeah.
And the story here also is because that's metal and it rides in a plastic part, we actually had to replace the plastic with a glass-filled nylon.
This plastic here.
Yeah, because when we went through the first round of cycle testing,
Yeah.
the first plastic that was PCABS wore out in
Yeah.
about 500 cycles.
So this is a glass-filled nylon here. So I think this is really interesting. We can see the feature that's right on the inside there, which has a groove. Can we see that okay, guys? And so the same thing, there's a feature on this. So when the shaft fits in, you're actually able to rotate and it stops. You can't turn it any further. Right. And so the metal injection molding is great. We do this for gears all the time. Yeah. And you wouldn't get this with a die cast method, or if you had to machine these, it'd be way too expensive. Right. It's actually very similar to metal 3D printing. We do a powder, we bake it afterwards and bake off a resin. So it's a really interesting process if no one's ever seen it. Last question here before we sign off. And give some recap thoughts. Biggest lesson learned from doing this. What would you do differently? Maybe I'll ask Emmy first, and then we'll go to ID. What would you do differently, or a big takeaway?
Well, actually, for us, the biggest lesson learned is that I think most of the things we did on this program went right, which is why we managed to get it from concept to market in 9 months. Yeah. And it's basically a lot of planning ahead and actually working with the suppliers. Because most of you who've worked with Asian suppliers before, they're used to doing things a certain way. Yep. They want to do things their way. Yep. And the headband is a great example. They actually didn't want to do the steel. They said, well, we always do plastic. It's cheaper, it's easier to assemble. It's like, no, but we need the steel to work. It's like, no, we want to make it plastic. So we actually say, guess what? Do it both ways. Make both prototypes. And we tested both of them, and guess which one worked. Yeah. So it's one of those like, hey, don't fight them, just work with them and figure out how to work around it.
And how about for yourself?
I probably have a skewed approach. I think it's for me, it's the very same thing. I think this is probably one of the most engineering and design collaborative involved projects that I've got an opportunity to be on. The biggest learnings for me were just marrying a lot of those high fidelity details with engineering and finding really beautiful solutions. Awesome. I think probably the bigger picture learning was getting into a big product category like this. Yeah. I think the big distinction, if you're doing something like headphones, is find a strong opinion on brand. Find a really effective way to communicate, to the consumer, the public, and having that point of view on that. Yeah. That's probably a huge thing.
Well, I want to thank you guys so much for the time. For myself, I think that this is what we try to do every day at Fictiv, is really uncover the hidden truth and all the knowledge behind what it takes to make physical products. I know our community, your community, really appreciates you guys taking time out of your busy day to share. So from everyone watching, a big thank you to you guys.
No, thank you. We love this. It's why we do what we do.
Yeah. So once again, I have Andrew from LUNAR. Thank you so much, and Terrence, thank you. I'm Dave from Fictiv. Please stay tuned for more of these in the future, and thanks for tuning in.